Okay, we're going to do some teaching on integration by parts. Now, integration by parts is a way of integrating a product. So there's a product, UV, but U and V have to be totally unrelated functions. So U is not a multiple or a factor of the differential of V, it's completely unrelated, like X and sine X. And the formula for integration by parts comes from a rearrangement of the product rule for differentiation. So if I look at a product and I want to differentiate it, the product rule would be you write down the first and differentiate the second, plus then write down the second and differentiate the first. And this rule for integration by parts comes from a rearrangement of this. And the rearrangement of this is that u v dash will then be equal to the whole of it dashed, take away v u dash. And now what I do is, if I integrate all aspects of that, then the integral of u v dash, or the integral of all of that differentiated, will just be all of that minus the integral of v u dash. So when we're integrating our product, we have to choose one of the terms as if it's going to be differentiated and one of the terms as if it's going to be integrated. And the rule we generally use is that we use the ordinary polynomial to be u and the other function to be v dash, except if the other function is ln, in which case it swaps around and the ln becomes u and the other term becomes v dash. And that's because ln is much easier to actually differentiate than it is to integrate. In fact, ln has to be integrated by integration by parts. So if we're going to now integrate this, I'll call ux and v dash sine x. U dash then becomes 1, and v, or the integral of sine x, is going to be minus cos x. So we've got all four terms now, so all we've got to do is substitute. So the integral of x sine x is u times v, which is minus x cos x, take away the integral of v u dash. Well, v u dash is minus cos x to the 1, and the integral of minus cos x is minus sine x. So we've got to be careful here with the signs. In fact, before I integrate it, I'm going to deal with those negatives. And the integral of cos x then is sine x. So minus x cos x plus sine x. And of course we've then got a plus c because it's an indefinite integral. And that's how you use the integration by parts formula to integrate a product. Now I'm going to do a second integral using one where ln is part of the product. And this is page 45 of the preparation book. And we're going to look at question 4a. And that tells us to integrate x squared ln x. Now in this case, the ln is always used as the u function. So u is ln x, u dash is then 1 over x, v dash is x squared, v is therefore x cubed over 3. And what I always do is get all four of those terms sorted out, and then I can just substitute. And if I go back up here, the integral of u v dash, so the integral of x squared ln x is u times v, which is x cubed over 3 ln x, take away the integral of v times u dash. Well, v times u dash is that times that, 1 over x times x cubed over 3, and that simplifies to the integral of x squared over 3, and that simplifies to minus 1/3 the integral of x squared, and if we integrate that we get minus 1/3 x cubed over 3, which is minus 1/9 x cubed. So the whole integral becomes x cubed over 3 ln x minus 1/9 x cubed, and of course then plus c, because it's an indefinite integral. And that's how you integrate using integration by parts.